presentation, I would like to have a note, because as you can see, the main subject of my topic is the micro and nanoparticles on the ceramic membrane. However, last year at this conference, I has presented about the microparticles. So this year, I will just present about the nanoparticle part.
Is it the second part?
Yes. I'll start my presentation. The content including 4 parts: introduction, material methods, results discussion, and conclusion. Firstly, I'll move to the first part, the introduction. As we all know, nanoparticles play an vital role in in a lot of fields, and they are used in many products, in that titan oxide, zinc oxide, and silicon oxide are used the most popular, and therefore they are discharged a huge amount into the environment and will affect significantly to the natural habitats. And we have different methods for removing the nanoparticle out of the solution, and one of these methods is membrane filtration. And because of the high ability of removing the nanoparticles, as well as using no chemical consumption, and also we don't create the secondary waste after the filtration. Therefore, membrane filtration is considered an effective method for removing the nanoparticle. And in the filtration of the membrane with the nanoparticles, there are many factors that will affect the fouling on the membrane, such as ionic strength, pH, pressure, temperature. However, there is one factor that is rarely concerned, and it is the charge of the particle as well as the charge of the membrane. So let's take an example. Like if we have a positive charge membrane and we have the negative charge nanoparticles, then the particles will create a self-fouling on the membrane due to the attraction of the particle on the membrane, and therefore the charge of the particle and also the membrane are the main factors that will create a significant fouling tendency on the membrane. And there's not much research in this nanoparticle charge and also the membrane charge, so a study about the effect of the nanoparticle charge is necessary. So the objective of this research, firstly, we will evaluate the effect of the nanoparticles. In this case, we have negative, neutral, and positive charge nanoparticle, and also we will filtrate it on the positive and neutral charge membrane. Besides that, we will add the organic matter inside the nanoparticle solution so that we can illustrate the real wastewater condition, and we will filtrate it on the ceramic membrane. So the main objective of this research is to determine the effect of the various charged nanoparticle in the wastewater on the operation of different charges ceramic membrane. Next, I'll move to the second part, the material and method. In this research, we will use 2 types of membrane. It is the ceramic membrane with the aluminum oxide and titanium oxide surface. The reason I will tell you later. This is the schematic diagram of the pilot scale ceramic membrane system, and as you can see, this is the condition of the membrane, and also this is the operating condition. Next is the experimental setup. In this study, we have 2 main stages. The first stage, I will filtrate the nanoparticle with the neutral charge, positive charge, and negative charge through the ceramic membrane with the positive and neutral charge. The size of the nanoparticle would be from 20 to 35 nanometer, and the concentration is 10 milligram per liter. At the second stage, I will add the humic acid as a representative for the organic matters in the solution, together with the nanoparticle filtrate through the same ceramic membrane at the positive and neutral charge. The humic concentration is 20 milligram per liter. And next, I will introduce to you how do we analyze the data. The first method that we use is the modeling method. In this method, we will take the data from the filtration, put it in the equation, and plot it into a linear graph. And for each linear graph, we will be able to identify the fouling mechanisms of the particle that created on the membrane. We have some type of fouling mechanisms such as like complete blocking, intermediate blocking, standard blocking, or cake filtration. And the next method that we use is modified fouling index. Using this method, we will be able to identify what type of cake filtration that the fouling created on the membrane. Besides that, we also use some other analysis such as measuring the nanoparticle concentration, zeta potential, particle size, and also the organic matter concentration in the solution. I move to the third part, the result in discussion. This is the pH that we use in this study is pH 6.2. The reason that we use this pH is because at this pH we have zinc oxide, titanium oxide, and silicon oxide nanoparticle. They have the positive charge, neutral charge, and negative charge respectively. And also at pH 6.2, the aluminum oxide membrane will have the positive, and titanium oxide membrane will have the neutral charge. This is the result of the filtration. Firstly, I have filtrated the nanoparticle through the two membrane, aluminum membrane and titanium oxide membrane. And the result I got is that firstly, for the MFI and modeling method, they show the consistent result that the main fouling mechanism on the membrane is cake filtration. Secondly, silicon oxide nanoparticle, due to their negative charge, so they have really strong repulsive force to each other, so they created a porous cake on the membrane. Thirdly, the neutral charge titanium oxide and titanium oxide membrane, they have the highest flux because they are at neutral charge. As you can see here, this is the filtration of titanium oxide, and they have really high flux as compared to the other nanoparticle. The reason is because they have neutral charge, so they have no interaction with the other components in the wastewater. And lastly, the zinc oxide nanoparticle, which have positive charge, they created the irreversible fouling on the membrane because they have really strong interaction with each other. Secondly, in the second stage, I have mixed the organic matter with the nanoparticles and filtered through the two membranes. And what I found is that firstly, for the neutral and negative charge nanoparticle, when we put them into the solution together with other organic matters, they have to improve the flux significantly. This is the filtration of humic acid, and this is the filtration of humic acid with the addition of the neutral and negative charge nanoparticle respectively. And secondly, as I presented before, this is the filtration of nanoparticle alone, and this red line is the zinc oxide nanoparticle, and they created the irreversible fouling on the membrane. However, when moved to the filtration with humic acid, the irreversible fouling has transformed into reversible fouling. This is the result of the measurement from the particle number in the solution and also the nanoparticle concentration. As you can see here, firstly, for the zinc oxide nanoparticle, they are not efficiently removed from the solution because they have really strong stability, so they stay alone and they have really small size as compared to the membrane size. So they there is no effective way that ceramic membrane can remove zinc oxide nanoparticle out of the solution. However, in the case of silicon oxide and titanium oxide, because they aggregated with each other, so they created bigger particles, and therefore they are easily removed by the membrane. As you can see here, this is the number of particles before the filtration and after the filtration. A ceramic membrane can effectively remove the silicon oxide and titanium oxide particle. This is the measurement of the humid concentration. As you can see, there is not much difference between before and after the filtration, which shows that ceramic membrane can hardly remove the organic matter because like humic acid have smaller size as compared to the membrane quantity. And finally, I move to the final part, conclusion. First conclusion is that the neutral charge nanoparticle created the lowest fouling tendency on the membrane because they didn't interact with other components as well as the membrane. The positive charge create irreversible fouling and negative charge create reversible fouling. So the particle at different charges will create different fouling mechanism on the membrane. Secondly, membrane at the neutral charge have the better filtration efficiency as compared to the membrane at the positive charge. Because like as I have explained before, the neutral charge don't have interaction with the components in the wastewater, so they have better filtration efficiency. And thirdly, when we put the humic acid into the solution, the zeta potential of the solution will transform to negative. And when we put humic acid into the neutral and negative charge nanoparticle, this particle will help to enhance the flux of the humic acid. And when we put humic acid with the positive charge nanoparticle, humic acid will help to transform from irreversible fouling of the nanoparticle into the reversible fouling. And the further study that we are going to do is that we can try to change the positive charge that used in this study, because like zinc oxide nanoparticle, they are related strongly inside the membrane, so they cannot be a good representative to the positive charge particle. And that's all of the presentation. Thank you for listening.
Thank you for your very organized